Okay, folks, this section is 2.2 is called direct variation. Um, it says direct variation is any formula written in the form y equals k times x. Okay, it says the word direct refers to what happens to the y value as the x value changes. Okay, so when we see the word directly, it means they're doing the same type of behavior. So it says y gets bigger when x gets bigger. Okay, and y gets smaller when x gets smaller. Okay, because one is doing the same as the other, that's called direct variation. Sometimes it's referred to as joint variation. Okay, joint because they are doing the same thing, they're together. If one gets bigger and the other one gets smaller, or one gets smaller and the other one gets bigger, then that's called disjoint or indirect variation. Okay. Here we call k the constant of variation. Okay. So it is called this because when we solve for k, it shows for all points except 0, 0, in which the quotient y divided by x equals k, regardless of the ordered pair. So I'll demonstrate that here when we do some examples. So we'll use the idea above to then determine if functions are direct variation functions or not. All right, so then the following functions determine whether y varies directly with k or with x. So if so, what is the constant variation? So that's kind of the structure here. Is can we determine that whenever I take a y value and divide it by its x, do I get the same k value back? If I take y divided by x here, so 2 divided by 1, that gives me 2. When I take 6 divided by 3, that gives me 2. When I take 8 divided by 4, that gives me 2. So because I'm taking a y divided by an x, a y divided by x, and each time I'm getting the same number, in this case k back, or 2, this is direct variation. And my constant of variation is that quotient that we kept realizing. Okay. Now here's a situation where maybe this definition is a little bit vague, because let's look at what we've got going on here. As x is getting bigger, so bigger from 1 to 2 to 3, okay, it's growing, y is getting bigger as well. Okay, but let's take y divided by x, and we get that. If I take 8 divided by x, I get that. If I take 11 divided by x, okay, 11 divided by 3 is less than 4, so it's approximately 3 something, okay. What is it? It'd be 3 and what, 2/3, so 3.6 repeating, okay. These are not all the same. Even though these got bigger and these got bigger, they didn't get bigger in the same amount or same ratio. So this is not direct variation. And that's something just in the structure of mathematics that we have to mention, is that when we write a phrase like this, this is not specific enough. It's pretty vague, and it leaves open to interpretation or open to having things being identified. If we went solely off of this, we have things being identified as being direct variation that would really not be direct variation. So what we do is we have to be a little bit more precise, and we maybe in this situation we create a formula that creates that precision then. Here the question is, does y vary directly with x? Well, can we, based on our definition, can we rewrite this so that it is equal to y equals some k times x? That's every equation that is a direct variation equation or function should be able to be written this way. So can I isolate y? Well, I divide both sides by 3 here. You get y by itself, so that's good. And now I'm going to get 7/3 times x. So does that model this? It does. This 7/3 is my constant of variation. So we're good to go. Now in this one, I can my y is already by itself. So now I need to, or at least isolate. I got to get that 7 on the other side. So I divide everything by 7 here. And I'll get y is equal to 2x plus 1. Is that of the form y equals kx? And it's not, because there's a plus 1 here. Okay? We can't have any extra stuff here. So this is not direct variation. And we could see that, we could recognize this if I were to make a chart of x's and y's for this particular situation. If I say, let's just say x is 1, we'll go 2, 3, and 4. If I plug 1 in, I'm going to get 3 back. If I plug 2 in, I'm going to get 5 back. 3 in will give me 7. And then 4 in will give me, what, 9? And if I divide these, y divided by x, like I did up here in these two examples, I'll get 3 divided by 1, which is 3. Here I get 5 divided by 2, which is 2.5. And right off the bat, we can then see that these k values are not the same. Okay, so this would not be direct variation. But we can go further if we want to. 7 divided by 3 is going to be 2 1/3. And then 9 divided by 4 is what, 2.25. So we can see that these values are not constant. These quotients are not constant when I take y divided by x. So that would not be direct variation. It says in direct variation, y divided by x is the same for all pairs of data where x does not equal 0. Obviously, x cannot be 0. We've been told we cannot divide by 0. So the idea is that exactly what I've been showing here. Any y value divided by its paired up x value should equal any other y value divided by its paired up x value. Okay. Knowing that x1 and x2 cannot be 0. So suppose y varies directly with x and y equals 9 when x equals -15. What is y when x equals 21? Okay. A couple different approaches you could take here. If we use this idea here, this should be true. So I should be able to say y1 over an x1 should equal a y2 over an x2. Okay. So suppose y varies directly with x. That's what this is saying here. We know that this should be true when that happens. It says, and y equals 9 when x equals -15. Y equals 9, so I'm going to let y1 be 9 and x1 be -15. When they say this right here, it's like they're telling me an x1 is -15 and a y1 is 9. So now the next question is, well, what is y when x is 21? So they're telling me another x value, a different x value, so I'm going to call that x2, and now it's asking what is y2. So I'm going to come over here in the second part of this equation. Okay, they want to know what is y, so I don't know that, so I'm going to leave that as y2 when x is 21. So now I go 21. Now I can cross multiply because it's a ratio equal to ratio. What I would do first is maybe see if we can reduce some stuff. So there's a factor of 3 that goes in both those. So we get 3 and 5. So we get 5 y2 when I cross multiply 3 and 5. We can actually even go, I'll leave it this way, because this 3 and that 21 can cancel as well, but we'll just leave this alone. So 5 times y squared, and then we get 3 times 21 is 63. So then y2 would be 63 divided by 5. Another way that we can do this is say, okay, suppose y varies directly with x, and we get y equals kx. If it varies directly, we know that that formula should be true. So then what we can do is say, well, y is 9, when x is negative 15. So I can do that. Now I don't know what k is in this case, so I can actually solve for k. So get 9 divided by negative 15 is equal to k. And now this piece of information gives me what I do next. It says, what is y when x is 21? Well, I know what k is supposed to. If it's very directly, I know k should be 9 over negative 15. And if x is 21, okay, we should be able to, obviously that's going to reduce to 3/5. I'll get negative 3/5 times 21, negative 63 fifths. Something with direct variation, and we're going to see some examples here of this in a moment. Everything in direct variation is going to be a line that passes through 0, 0. Okay. So right now, I know that we said our k value was negative 9/15. So if I just write y equals negative 9/15 and then times x, it should graph that. And we see then when I choose, so when x was negative 15, so x is negative 15, which would be right here. Let's go see what the y value is right there where my cursor is. So I gotta scroll over. You see it is at 9. So that's true. So let me just plug in that point, negative 15 comma 9. You see it does show up on that graph. Okay. Now the question is, well, what should show up when x was it 21? Let me double check. When x was 21, what should the y value be? Well, we could go over here to 21, okay, and we said it should be negative 63/5. So let me type in 21, negative 63/5, and we see that it does indeed show up on that line then. Okay, so every point on that line is going to be related to an x and a y in that way, in that fashion. So let's go to this next one. It says if a salesperson's commission varies directly with sales. Commission is, let's say that I'm a car salesman. I might get like 3% of what the final sale price of the car is. So let's say a car sells for $10,000. Okay, I might make like an hourly wage of, I don't know, like $3 or $4 an hour. Usually when in a job that makes commission, they don't get minimum wage because I get a percentage then of this sale, okay, or the profit. Let's say this was the profit of a car. So I might get 3% of that. So 3% of 10,000, we'd multiply that out, and that would be what I take home, okay? A lot of realtors will make 3% on like 3 to 5% on the final sale of a home. So a salesperson's commission varies directly with sales. It says for $1,000 in sales, the commission is $85. Okay. Now that is dependent on that number right there. So right there, we're being told what our X1 and Y1 are. Okay. So this says what is the commission for $2,300 in sales? So $2,300, the amount in sales is the X2. They want to know what is the Y2. Well, I don't know that. So we can use that idea that Y1 over X1 should equal Y2 over X2. Something about proportions, if you forget which one should be on top, it doesn't matter. You can write it as X1 over Y1 and X2 over Y2. Because when I cross multiply, I still get the same products that way. But now I'm just going to plug this stuff in. So y1 was 85, x1 is 1,000, y2, I don't know that, I'll leave it alone. X2 was 2,300. So all I'm going to do is I'm going to say, okay, well, y2 times 1,000, I'm going to cross multiply, those two things multiply together, is equal to then 85 times 2,300. So then y2 is going to be 85 times 2,300 divided then by this 1,000. So let's just see what that turns out to be. Grab Desmos, maybe the easier thing to do. So we had 85 times 2,300, and we'll divide that then by 1,000, and I should make $195.50. 195.5. And that's one way of doing it. Alternatively, we could do this. I think that's the easier way to determine a question like that. But like I said, if we know commission varies directly, okay, commission varies directly with sales, and we just got to pay attention to what is when it says commission varies directly with sales. That means commission. Something like that. That's the way we could write that, where commission is the Y value and sales is the X value. So when they say that we make $85, so Y is the dependent variable for $1,000 in sales. We can solve for K now, and K we would write as 85 over 1,000. So that then, when I plug back into Y equals K times X, now I've got a specific X value that I'm going to be interested in, and it's the $2,300. That's the second scenario. If you think about that right there, that is identical to that right there. But like I said, I think doing it in the red, some of you might prefer this red route. I think it's easier using this cross product. It says graphing direct variation. This is pretty easy. Direct variation is always going to pass through 0, 0. So 0, 0 is going to be a point that we need. And then you can choose another point. Doesn't matter what it is. Okay. Those of you that understand slope already can use this. There's your rise and there's your run. So I can go up 3 and then over 4 and put my point there. Okay. If I'm using a T-chart to find another point to graph, and there's a fraction out here, my suggestion is that your value you choose as an input. So I chose X to be 0, so Y would be 0. That's an easy one. And that's always going to be true for direct variation. I would then choose multiples of that denominator. It's going to make things a lot easier for X. So I'll put 4 in here. And so then I have 3/4 times 4. 4's cancel out. Leaves me 3. I can plot the point 4, 3. So start at 0, 0, go to the right 4, and then up 3. And what do you know? It gives me the same point that rise over run gave me. If I tried 8, okay, I would have 3/4 times 8. So the 4 and the 8 cancel, leaving me 2. So 3 times 2 is 6. So 8, 6 would be another point. But I only need 2. And once I have those first 2, I'm just going to create as straight a line as I can. This point here should actually be -4. -3 should actually go through that point there. But that's graphing direct variation. Same thing here. So this is direct variation. So it goes through 0, 0. Okay. Now because there's no fraction here, if I try my, try 0, 0. Let's try like maybe 3. If X is 3. Plug that in, I get -6, so 3, -6. Right there. And now just connect those. If I wanted to try like -1, I could have. -2 times -1 is 2. So So -1, 2 should be plotted. So that is direct variation. Just a key thing to know. As x gets bigger, y gets bigger. As x gets smaller, y gets smaller. But they do that to when we divide corresponding x's and y's in the order of y divided by x. The quotient always has to be the same. If the quotient differs, like we saw here, or like we saw here, then it is not direct variation. Okay? Direct variation, the constant of variation, is that slope or rise over run that you might be familiar with from other courses. If you have any questions on this stuff, please do not hesitate to reach out. My plan for this group, this integrated class, is for you guys still to have quizzes on Friday. Regardless of my presence, you'll still be able to use your notes. I will monitor you remotely during that time period, so I'll see what you're being able to do on your computers and that kind of stuff. I only want you using your notes. I don't want you using Google or anything like that. So I will monitor that. But like I said, if you have any questions about anything, do not hesitate to reach out and ask.